Hi, my name is Jonathan, and welcome to Cisco SD WAN hybrid scenarios. Basically, we're going to describe how you deploy that SD WAN solution and the traditional WAN solution side by side. Basically, what we're going to be doing is a bunch of routing redistribution. So stay tuned. So when we're done with this, basically, you're going to be able to describe those design considerations we're going to have for those hybrid scenarios. And we're going to describe how those SD-WAN sites can interoperate with non-SD-WAN sites. One of the key things here is that ideally what you would want to do is use the SD-WAN solution as your primary ingress and egress device. But sometimes that's just not possible because, depending on the considerations that are in place. So if you have an existing Cisco router that's running unified communications or uses E-Blade or some other service that the SD-WAN solution doesn't provide, we'll have to keep that existing solution in place and run the SD-WAN solution side by side. And we'll go through each of those scenarios. So before deployment or that migration, you're going to have to consider a couple of key design requirements that might influence your solution. Because the SD-WAN core value here is that support for multiple transport networks, you're going to have to determine whether or not the site is connected through one or two transport circuits. You're going to have to consider the type of transport network. Pure MPLS deployments usually have consistent address space between VPNs, whereas in the case of internet connections, you might have potential address overlaps, which could impact routing. You also have to consider your redundancy requirements, which might eliminate some simplistic solutions. On the LAN side, you must consider active and standby redundancy requirements before deployment. You must also consider internet access. In some scenarios, internet access goes through the data center. In other scenarios, direct internet access per site or port region is required. And internet access requirements also have an important impact on how to deploy pure or hybrid SD-WAN solutions. So, while some deployments will be pure SD-WAN deployments, meaning we only have an SD-WAN device as our connectivity to the site, there's going to be a couple of reasons where we prefer a hybrid deployment, where we have both, where this SD-WAN coexists with your traditional network service. One such reason could be requirements for advanced features not yet available on those pure SD-WAN solutions. Examples are unified communications. For example, let's say your existing MPLS router terminates a SIP trunk bound to the MPLS customer edge IP address, okay? Or a very specialized firewall or content inspection engines. Another reason could be increasing virtualization in the branch offices, where different virtual machines are deployed on a UCS E-Blade on Cisco ISR routers, or the deployment of ENCS devices. This module is going to examine such hybrid scenarios and explain how to migrate from a traditional network to the Cisco SD-WAN, both pure and hybrid. And also the Cisco Enterprise Network Compute System, the ENCS, is a line of compute appliances designed for SD-WAN, for Cisco branch and enterprise network function virtualizations. And the ENCS hybrid is a hybrid platform that combines the best attributes of a traditional router and a traditional server and offers the same functionality with a smaller infrastructure footprint. Offered with a Cisco Integrated Service Virtual Router, basically the ISRV, and Network Functional NFV infrastructure software as the hosting layer. On a more granular level, you must consider the following three areas. Controllers. What are the methods of deploying those controllers, and how will that impact all future network operations? In a cloud model, all devices, controllers, and edge devices must be able to reach the controllers in the cloud. Therefore, internet access is highly important and must be planned accordingly with high availability. Redundancy and scale also might impact operations later. For example, in a global network, you might distribute vSmarts into regions, and vEdges must be able to access the vSmarts accordingly. You must place vBonds carefully such that potential NAT functions can be detected from all devices. vBond redundancy requires DNS load balancing, which you must consider also. In the data center, when deploying SD-WAN, along with the previously mentioned topology considerations, number and type of transport networks, you must consider the design of routing, firewalling, and traffic paths during a migration. For example, you must consider QoS requirements in all data center devices on the traffic path. Also, traffic engineering might impact operations in the data center. At the branch, requirements for direct internet access are important. Also, you must consider services that must be available at the branch and which of those services that you can centralize in the data center versus which services you must deploy locally. This may have an effect on the deployment options. So we're going to use some terms that you're probably going to be new to you. Non-SD-WAN sites and prefixes, those are referred to those traditional MPLS VPN sites. The main point is we assume that address space in the SD-WAN and non-SD-WAN space is coherent and non-overlapping. We also have SD-WAN prefixes and routes. Those always refer to the overlay, in other words, the service side. And then we have the transport prefixes, and always refer to the underlay. A transport prefix typically leads us through to the underlay to another vEdge device. So this module is going to focus in particular on the following design goals. The benefits from the SD-WAN solution, its simplicity, its ease of supporting multiple transport circuits with advanced policies, and how do we maintain advanced features and deployment models that are not yet supported in the SD-WAN platforms. For example, advanced virtualization capabilities, UCSE blades, unified communications, etc. For migrating to an SD-WAN hybrid solution, a smooth transition is of paramount importance without loss of service for redundant sites with a minimal disruption for non-redundant sites. The simple hybrid model is an inline deployment model where the vEdge and the service router with advanced network services are in line. The vEdge router is deployed in front of the service router. So here's our service router. And then we have the vEdge router, which is connected to the two connections. Basically, that service router is going to host all the services. So this is where your unified communications, UCSE, etc. And WAN optimization or anything else are going to sit behind it. This is simple if you control the routing to the MPLS provider and can send prefixes to them. However, if this CE device is actually controlled by your provider, that may not be an option. So the vEdge here is going to manage the transport network connectivity, the underlay, transport policies, and routing distribution from OMP into the local routing protocol, OSPF or BGP. From an SD-WAN perspective, seen from the vManage, the site is a normal SD-WAN site because the service router is hidden behind the vEdge. And the vEdge router learns all SD-WAN and non-SD-WAN prefixes through OMP and redistributes them in the local routing domain. In the reverse direction, the vEdge router redistributes local prefixes into OMP. SD-WAN and non-SD-WAN interoperability is maintained through the data center hub. All traffic destined toward non-SD-WAN sites goes through the data center. This setup is not redundant, so the loss of either vEdge or service router leads to a loss of service at the site. So the point making here is this site is not SD-WAN. So how do we connect this site to this site, which is? And the answer is we go through a hub that has both of those connectivities to it. So these non-SD-WAN sites would basically be redistributed into SD-WAN through that data center. In the parallel deployment, the vEdge router is deployed next to the existing router. On the transport side, the vEdge has two transport networks with two TLOCs and is able to fully use both transport networks and failover between them. On the transport side, the services router is invisible from an SD-WAN perspective and is simply part of the larger network, part of the transport network. On the service side, non-SD-WAN networks are routed through the data center and from the data center through the overlay network. Seen from the local side, a non-SD-WAN router and an SD-WAN edge are treated and routed exactly the same. Okay. So basically what we would end up having is a certain amount of differentiation between the two of them. So this router would be used for MPLS connectivity, this for internet. We'd still build tunnels to the sites through the SD-WAN, and then the MPLS router would also have these routes sent back to them so that they would have full connectivity as well to the same SD-WAN sites. The routing setup on the services router is, however, very specific. First, because services are running on this router, the router must see both directions of traffic on the service side, the overlay. Therefore, the vEdge must route traffic to the LAN through the services router by setting a local priority or by policy routing. So the problem is this. If I route traffic this way, and then it comes back that way, we have asymmetric routing and we can have some serious issues. Well, the solution, of course, is to send the traffic back that way so that it still comes back from the same router that the LAN side is still talking to. So basically what we would end up having is we have two routes for local LAN traffic. One high preference through the services router, and other low preferences directly. So if we do lose this guy, we'd still be able to route directly through him. The services router must route all overlay traffic to the V-edge. So if you are connecting to a SD-WAN site, you would route that way. If you're connecting to an MPLS site, you would route that way directly over the MPLS. Okay. On the transport side, the underlay, the services router announces a single prefix, that of the V-edge TLOC MPLS, so that other V-edges can reach the local V-edge through the MPLS transport. The service router must be able to route to all other V-edges. Strictly speaking, the services router acts in both overlay and underlay, and you can use a separation by using a VRF for the services side interface to enforce a strict separation between both sides. The problem with this is we have limited redundancy. If the service router fails, traffic falls back to the internet transport, but the services are no longer available. If the V-edge fails, the site loses all connectivity. However, either transport network can fail. The V-edge can use either one. It's also possible we can provide a direct connection to non-SD-WAN sites locally on site. We'll show you that on the next slide. So for this scenario, the services router announces the local prefixes into the MPLS cloud. In addition to those directly connected VPN 0 interface on the V-edge. So we're also advertising this route, this default route from here. In this case, it is probably more practical to default to the MPLS cloud and on the link to the V-edge to explicitly route to all service-side SD-WAN prefixes. As in the previous case, a separation by using VRFs on the service router would allow you to point the default to both the V-edge on the one VRF and to the MPLS cloud in the other VRF. The V-edge here continues to route for both transports, as in the previous case. On the service side, non-SD-WAN networks are now routed directly through the MPLS cloud and do not traverse the SD-WAN cloud. Note that the SD-WAN policy settings are therefore not applied to this traffic. So because we have traffic routing directly through the services router, policies that sit on the V-edge and are sent from vSmart would not apply to that traffic because our traffic doesn't flow through that device. Note, this design also has limited redundancy. If we lose the services router, traffic falls back to the internet transport, but the services are no longer available. So for example, if we've got UC services, etc. So if we lost this router, we'd lose the UC services, but we'd still have connectivity. You get some things and you lose others. In addition, if there's no connection to the data center to non-SD-WAN sites, connectivity to all non-SD-WAN sites is lost. If the V-edge fails, the site loses connectivity to SD-WAN sites, but not to non-SD-WAN sites. So in summary, the hybrid SD-WAN design might be necessary when advanced services are required that are not yet available on the Cisco SD-WAN devices. We don't support voice yet on the SD-WAN. We don't support wide area application acceleration or UCSE modules. So if you're dependent upon those services, you're going to want to keep those in an existing Cisco platform running iOS XE. You can deploy hybrid solutions with SD-WAN routers and service routers inline or in parallel. The best case will always be inline. It's the simplest way to set these up. Thank you for watching, and stay tuned for more on hybrid solutions.